Welcome to Diagnosing Weight Stats. So the first thing you're probably asking yourself is, what the heck is a weight stat? Well, weights, which is what the weight stats are built off of, are simply what SQL Server is waiting on as queries are running. There's lots of different kinds of weights and lots of specific weights. What I mean by lots of specific kinds of weights is there are over 600 different weight types in SQL Server 2012. Every version of SQL Server since the weight stats were first exposed to us in SQL Server 2005 has added more and more granularity to these weight types. Some of these weight types are harmless. Some of them are very, very misleading. There's two really common misleading weight types. The first one is SOS scheduler yield. Often when people first see this, they see this as a problem they don't really know how to solve. And what this actually means is that SQL Server is simply pausing the query so that it can go do something else with that scheduler. So I'm going to dive down a bit of a rat's nest for a minute here and talk about how the SQL Server engine actually works. So within SQL Server, we have threads. Each of these threads is assigned to a scheduler. The scheduler is what lets SQL Server know when it's time to do stuff. And it's literally just a queue of things that SQL Server needs to get done. Everything that SQL Server needs to get done is run through these queues. Everything that needs to get done is done in 4 millisecond chunks of time. Once something has run for 4 milliseconds, it's descheduled, and its scheduler is given to the next thing in the queue. The thing that was running that's just been descheduled is put in the back of the queue and is told to wait for its turn at the next 4 millisecond cycle. So if you've got a long-running query that's extremely complex, you'll see this SOS scheduler yield popping up on your server. Because SQL Server is going to be descheduling these queries because they take so long to run and require so many resources. So all it's simply doing is telling this query, hey, go to the back of the line, let something else through. This is how we can get multiple threads happening all at the same time, is through this schedule and queue process. The other misleading weight type that really screws a lot of people up when they first get into SQL Server is the CX packet weight type. This is often, again, considered to be part of the problem or to be the problem. And what you'll see is you'll see people trying to eliminate the CX packet weight type, thinking that if they solve this problem, their problem goes away. How people tend to do this is by simply not making queries parallelize anymore, because that makes the CX packet weight type go away. The reason that works is all CX packet is simply telling you that you've got multiple threads running, and the thread that's currently waiting on a wait type of CX packet is simply waiting for some other thread to finish. If you look in the sys.dm_execute request DMV that we look at in the locking and blocking video, that particular DMV is going to show a blocking ID matching the session ID. And when you look into the wait type for that particular session, you're then going to see that the wait type is of CX packet. Now, this doesn't mean that parallelism is causing some sort of problem in slowing the query down. What this means is simply that one of the other threads for that query is not finished, and it's waiting for something else. That something else is your problem. That's the thing you need to be solving for, not for CX packet. Now, typically the other thing it's waiting for is going to be something fairly standard, I/O being the biggest problem. There's a lot of other common wait types that you're going to see. Those are going to be things that look like page latch, page I/O latch, various locking wait types that specify LCK_something, and then things like async network I/O. These are all things that you can kind of do stuff about. Async network I/O, not so much. The other stuff is giving you a very good idea of what's going on. Well, realistically, all these wait types are giving you a very good idea of where the bottleneck is. It's a matter of trying to figure out how to solve that bottleneck. Now, before we can solve the bottleneck, we need to know how to find the wait information. So there's a couple of DMVs you're going to look at. You're going to look at sys.dm_os_wait_stats. That's going to give you specific information at the cumulative level about the wait stats. So it's going to give you just a dump of all the wait stats in SQL Server and what the various wait types are for those individual wait stats. It's going to tell you how long the longest wait was, what the total wait time for that wait stat was, and how many times it's waited for that specific stat. The second one that you're going to be looking at is sys.dm_os_waiting_tasks. This is going to give you detailed information for each task in SQL Server that's currently running and what it's waiting on and how long it's been waiting. You can also get some basic wait information from sys.dm_execute_requests. So let's go ahead and look at these DMVs and see how we can use these to dig into the server and find the information we're looking for. So you can see here we've got Management Studio connected again. And again, we've got the same queries that we've used in a couple of different videos now that you may have seen. Let's go ahead and do a begin tran. And let's go ahead and do that insert. This is a nice, easy way for us to look at waits. So let's go ahead and query from sys.dm_os_wait_stats and look at the stats that we could be waiting on. So I'm going to run this a couple of times now and see if any of these numbers are changing, and they're not. So let's go ahead and sort this by wait time_ms in descending order. This gets our worst wait times towards the top. Now you can see here we've actually got some really high numbers right now. And that's because these are the general waits for the entire time that the instance has been running. So the one I'm really interested in right now is one that's currently at row 13, LCK_M_S, because I know that's the lock that's been taken over here. Now let's go ahead and run a query that's going to bump up against that. So we're now waiting. Let's see what happens to this lock_M_S wait type as we rerun this query. It's not changing. So let's go ahead and see why not. We do this by looking at the sys.dm_os_waiting_tasks. Now this is giving us a whole lot of information. Specifically, we want to look at session ID 52. This is telling us we're waiting on LCK_M_S. We're being blocked by session 55. And we've been waiting for 36,000 milliseconds. Now, as we close that transaction and reopen it, we can see our waiting task count going up, but we don't see our wait time and our maximum wait time increasing. And this is probably because these transactions are never actually completing. As you can see, once they complete, we now increase our wait time. The reason that we're not increasing the wait time before now is because these transactions were simply never finishing, so we couldn't consider their wait times as part of it. Our waiting task count was going up, but our wait times weren't. So as you can see, I've rerun my queries and I'm now waiting again. Before that happened, we had a waiting task count of 15, a wait time of 379 seconds and 22 milliseconds. We run this query again, our wait time stays the same, but our waiting task count does increase. So the important thing is to look at the OS waiting tasks and see what our specific wait type is and what our wait resource address is. We can also look at the resource description and get a fairly plain English description of our wait that we're actually waiting for. You can see here we're waiting for a row lock, file ID 1, page 24888, database 9. We can see the lock ID, the mode, and the allocation ID of that specific object. Let's go ahead and take a look at sys.dm_execute_requests and see what this all looks like in there. Again, we have a lot of information for a variety of sessions because there's a lot of sessions running. Let's go ahead and look at the specific ones for session 52. We can see here again the lock type, the wait time, the most recent wait type prior to the current wait type, the session that we're being blocked by because we are being blocked by a session, and the wait resource. Again, this is giving us a specific database, file, and page number that we're waiting on. Now, if we look at session 55, we're not going to see anything because that session's not actually waiting on anything. If we look at session 55 on OS waiting tasks, again, we're not going to see anything because that session's not waiting anything. It's done waiting. Let's go ahead and commit that And we'll see that the information for session 52 now goes away as well, because session 52 is not waiting for anything, and there's no request currently being executed. So as you can see, by using these DMVs, we can see exactly what we're waiting on and who we're waiting on if we're waiting for a specific session. So in summary, the waits are simply what SQL Server is waiting on. We're not doing anything fancy to figure out what this stuff is. There's just some basic DMVs we can use to figure out what we're actually waiting on. Now, there are a lot of wait types in SQL Server. Obviously, I have not gone through them here. So you need to look at what these wait types are and learn the ones that are fine, the ones that are problems, and the ones that are misleading, and what those misleading ones actually mean. Now, some of these wait types are not going to be fixable within SQL Server. For example, if we're waiting on I/O, we may just need to upgrade the disks to faster storage. Maybe we need to get some solid-state drives to fix the I/O waits. Or we could be waiting on domain authentication. That's going to show up as a wait as well within SQL Server if we're waiting for the operating system to return some sort of authentication information to us. There's a large variety of these external wait types that you'll need to look at and be familiar with. These are all going to be the ones that start with preemptive. Those are the ones that are waiting on something external from the SQL Server database engine.